This is lesson 9.1 on frequency distributions and measures of central tendency. A frequency distribution is a table of collected data from a random sample grouped into equal intervals. Below is an example of a frequency distribution table, and you can see that we have our intervals here, and the frequency is how many are in that interval. So for this particular entry, there were 5 people that weighed between 60 and 62 kilograms. 63 to 65 kilograms, there were 18 people. 66 to 68 kilograms, there were 42 people. 69 to 71 kilograms, there were 27 people. And 72 to 74 kilograms, there were 8 people. The frequency, the relative frequency was also available on this table, but we're really only concerned about the interval and the frequency here. Frequency meaning how many values were in that range. Example 1, a survey asked a random sample of 30 business executives for their recommendations as to the number of college credits in management that a business major should have. And we're going to group the data into intervals and find the frequency of each interval. For my table, I'm going to make my interval 5 units in length so that I have my credits going from 0 credits to 4 credits, 5 to 9, 10 to 14, 15 to 19, 20 to 24, 25 to 29, and 30 to 34. And then I'm just going to count how many entries, or in this case college credits, were in each interval. For 0 to 4, I had 3 entries. I had 3, 0, and 3. So that's my frequency. There were 3 entries. For 5 to 9, there were 4 entries. 1, 2, 3, 4. And for 10 to 14, there were 6. For 15 to 19, there were 8. 20 to 24, 5 entries. 25 to 29, 3 entries, and 30 to 34, 1 entries, for a total of 30 entries there. Now we can take our frequency distribution and graph that using a histogram. A frequency polygon is really just a histogram, but we take midpoints at the top of our histogram bars and connect them with straight lines. So a frequency polygon is a graph that illustrates a grouped frequency distribution. The polygon is formed by joining consecutive midpoints of the tops of the histogram with straight line segments. So that's what we're going to do on the next page here. You can see an example of that where here are our histogram bars. You can see it more clearly this way. And then what they did is they took the midpoint at the top of the bar and connected those with straight lines. And so here is your polygon. Obviously, it's just not a regular polygon. We're going to draw a histogram and a frequency polygon for the distribution from example 1. So you'll want to go back to example 1 and look at your frequency table. So I want to make this really just the first quadrant of a coordinate plane. And I'm going to have my frequencies listed on my y-axis. I didn't have anything go over 10, so I'm going to label it as such. I had 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 up here. And then on the bottom, I'm going to have my credits, which are really my intervals. 0 to 4, 5 to 9, 10 to 14, 15 to 19, 20 to 24, 25 to 29, and 30 to 34. And I'm just basically going to copy my frequency distribution onto my histogram. So that's 1, 2, 3, 6, 7, 8, 9, and 10. I had 3 entries for the 0 to 4 interval, so I'm going to mark that. I had 4 entries for the 5 to 9. Six intervals for 10 to 14. 8 for 15 to 19. 5 for 20 to 24. 25 to 29 was 3. And 30 to 34, I had 1 entry. And then what I'm going to do for my frequency polygon is I'm going to find the midpoints of each bar on my histogram and just play a little connect the dots. Now I need to also bring it down to the x-axis. So I'm going to kind of extend there on each end about the width of one of my intervals and find what would be the midpoint at the base as well. And then connect the dots. And that's your frequency polygon. The next part we have is the arithmetic mean. Of a set of numbers, and that's the sum of the numbers divided by the total number of numbers. We mark that with, you should put a little line over your x, and this means the mean, the average, and this symbol is for summation, and it means take the sum of all your x values, which are all of your entries, and n is the number of entries. Example 3 says the number of bankruptcy petitions filed in the U.S. in the years 2000 to 2005 are given in the table, and we're going to find the mean number of bankruptcy petitions filed annually during this period. All we're going to do is add them up and divide by how many entries we have. We have 6 entries. We have 1253 plus 1492 plus 1578 plus 1660 plus 1597 plus 2078. And we're going to divide that by 6 because that's 6 entries. The mean will look like 9,658 over 6, and when you divide that, that's approximately 1,610. That's in thousands. If we were finding the number then, that would be 1,610,000 petitions. Example 4 says find the mean for the data shown in the following frequency distribution. Really, they've already added them up and they tell us how many numbers we have. It's just how they go about that. We see the value for each, or the entry is 30, and there were 6 of them. So in order to get this sum, they took 30 times 6 and got 180. And so it was a quicker way of adding them up. Instead of saying 30 plus 30 plus 30 plus 30, they multiplied first. Then they added all of those totals, and they got 1,395. So the mean for that, I'm going to take 1,395 and divide by 40, and you should get 34.875. A similar thing's happening with the next problem. Example 5 says listed below is the grouped frequency distribution for the 30 business executives described in example 1. Find the mean from the grouped frequency distribution. Again, we're going to find mean. We have a total of values, and the number of values is 30. And so to find the mean, we're going to take 465 divided by 30, and that equals 15.5. The last problem was an example of the mean of a grouped distribution, and what they did, you'll see in that last column, is, again, they did a summation of, this is the product of X and F, where X is your midpoints and F is the frequency. And so they took the sum of those. We're going to look at some other measures of central tendency here, the next one being the median. The median is the middle entry in a set of data arranged in either increasing or decreasing order. We want to find the median for each list of the numbers that follow here. For problem A, they're already listed in increasing value, so we don't have to rearrange. And the middle value here, since we have 7, an odd number, there is a middle, and that is 20. Now for the next one, B, it's not written in increasing or decreasing order, so we have to do that. We have 5, 7, 10, 11, 13, 15, 19, 30, and 39. There are 9 pieces of data. Anytime there's an odd number of values, we do have a middle, and in this case, it's 13. Again, you'll have to foresee, you have to list them in order from smallest to largest. In this case, we have 32, 47,